we want to evaluate or simplify each radical. Let's begin by looking at the definition of the principal nth root. If a is a real number with at least one nth root, then the principal nth root of a, written using this notation here, where we say the nth root of a, is the number with the same sign as a that when raised to the nth power equals a. The index of the radical is n. Looking at number 1, we have the fourth root of 16. To simplify or evaluate, we need to determine what real number raised to the fourth power is equal to 16. Notice how for this radical, the index is 4, giving us the fourth root of 16. If we're not able to determine what real number raised to the fourth power equals 16, it's helpful to look at the prime factorization of the radicand. So for number 1, let's begin by determining the prime factorization of 16. 16 is equal to 4 times 4. 4 is equal to 2 times 2. Notice how 16 is equal to 4 factors of 2. So the fourth root of 16 equals the fourth root of 2 times 2 times 2 times 2, which we can write as the fourth root of 2 to the fourth. So because 2 to the fourth is equal to 16, the fourth root of 16, or the fourth root of 2 to the fourth, simplifies perfectly to 1 factor of 2. Notice written in this form, we can think of the fourth root as undoing the fourth power, giving us 1 factor of 2. So the fourth root of 16 equals 2 because 2 raised to the power of the index, or 2 to the fourth, is equal to the radicand of 16. Next we have the fifth root of negative 32, so we're looking for a real number raised to the fifth power that's equal to negative 32. Let's ignore the sign for a moment and determine the prime factorization of positive 32. Well, 32 is equal to 16 times 2, and we already know the prime factorization of 16 is 4 factors of 2, which means the prime factorization of 32 is equal to 5 factors of 2, but we're trying to determine a real number raised to the fifth power that's equal to negative 32. But because the product of an odd number of negatives is still negative, we can write negative 32 as 5 factors of negative 2. So the fifth root of negative 32 equals the fifth root of negative 2 times negative 2 times negative 2 times negative 2 times negative 2, which we can also write as the fifth root of negative 2 raised to the fifth power. And because negative 2 raised to the fifth power equals negative 32, the fifth root of negative 32, or the fifth root of negative 2 to the fifth, equals 1 factor of negative 2. Again, in this form, we can think of the fifth root as undoing the fifth power, giving us 1 factor of negative 2. The fifth root of negative 32 equals negative 2 because negative 2 raised to the fifth power equals negative 32. And now for the last example, we have the sixth root of negative 64. So we're looking for a real number raised to the sixth power that equals negative 64. Again, let's ignore the sign for a moment and determine the prime factorization of 64. Well, 64 is equal to 2 times 32, and we already know the prime factorization of 32 is equal to 5 factors of 2. So we know 2 raised to the sixth power equals 64, but we're looking for a real number raised to the sixth power that's equal to negative 64. Unfortunately, in this case, if we raise negative 2 to the sixth power, we still get positive 64 because the product of an even number of negatives is positive. So because there is no real number raised to the sixth power equal to negative 64, this does not simplify using real numbers, and therefore we just say the result is not real. I hope you found this helpful.